everyone. My name is Brigid, and I am going to be doing some post-processing today. So that's what we're going to be talking about. My name is Brigid Long. I am a strategic account specialist here at Formlabs, here to talk to you a little bit more about the post-processing journey, the things that you can do with that, and some tips and tricks about some of the things that I have definitely heard from all of you about like what is difficult about this. So I want to share some of those things. I will have a friend come join me a little bit later on, but I'm going to start you out for this session. So I'm going to start with how do we actually define post-processing? This is a little bit of a challenging one because everyone kind of defines it differently depending on what they actually want their end result to be. So some people define it as like just washing and curing your parts. Some people define it as all of the things that they do, like sanding, cleaning, all of those things. We actually loop all of those into one big kind of like holistic collection. So on the services team, for the most part, if you want to talk to us about post-processing, we will talk to you about anything that happens to your print after the print has actually completed. This is washing, curing, sanding, all of those things, depowdering, and also like blasting and polishing, all of those things. That's all kind of like under the post-processing umbrella. The topics that I'm going to cover today are kind of a smattering across both SLA and SLS. I kind of wanted to be able to cover both topics to some degree, so that's kind of what we're going to be doing today. So we're going to do support removal, dyeing, electroplating, and polishing. So we're going to do just like broad smattering from very easy entrance to much more complicated and a little bit more challenging, but also see what kind of like options are out there in the world as well. So we're going to start with support removal, everyone's least favorite thing to do. This is one of our biggest challenges and biggest complaints whenever we are talking to users about what can be done about support removal. How do I make my supports look smooth? How do I do this? So there's no like magical way to make it all better. However, there are some tips and tricks that I can offer you to kind of like help with that. Kind of like the beginning things that we always tell our users is that like you can use the flush cutters that we send with our SLA printers with our finishing kits. This is a good like starting point and a good way to start your post-processing journey. You can use that flat edge to get really close to your parts and snip off very close so that you're not like removing additional material, but you're also like removing whatever supports that you need to. This becomes a little bit more challenging when you have a very dense like forest of supports though. So I am here to offer some additional tips and tricks. Starting with Dremels. Dremels with like a cutting disc on them are actually super popular and very handy in our dental and medical space. However, whenever I go and I talk to an engineer and they're like, how do I do this? What am I supposed to do? Usually I'm just like, have you ever considered using a Dremel with a cutting disc? And they're all like, you know, I never really thought about it. So it's not really as popular amongst like the masses, but it can really speed up your post-processing just like in general, especially if you have like a ton of like supports, like a really big part with a very dense forest of supports. This can be a way to kind of like speed up removing all of those. So you can take a giant cutting disc and actually just like cut through, get the base off, and be able to see what you're working with a little bit easier, as well as just like remove the bulk of that like extra material that like you're no longer going to need, and you could just get rid of it, get it out of your face. If you get really good at it, as most of our dental folks probably know, is that you can actually finish your parts this way as well, for very like fine detail things. A lot of like super small prints, you can actually get in there with your cutting disc and smooth out the surface. I say this with a little note of caution. When you start out, you may make some mistakes and you may cut into your model a couple of times, but with a light hand, you can usually get like a very, very smooth finish that is honestly preferred by a lot of people who are making like dentures and other medical appliances to make a nice smooth finish. So that's kind of like a if you're thinking about it, it does help speed things up, but also can be used as like a more detailed kind of like brush as well. On that note, you can also use a hobby knife. So getting a like really small blade to kind of get as close as you possibly can to your part without digging into your part is going to leave you a very easy to clean surface, and or just like a surface that is not going to be like pokey to the touch, even without any additional sanding. If you follow along the curves, it makes it really, really smooth, makes it really nice, and can really help. This is mostly used by people who are printing much smaller things. However, I have seen people use much larger parts and go in with like some of like the finer details and really like cut out like those little support pieces that they really want to make sure are actually like well-defined and you're not like cutting those off by accident. Or sometimes with your flush cutters, you'll like snip a support and it will break off a piece. This can give you a little bit more control on that and help you out. And then there's our favorite secret third option at Formlabs, which is just ripping the supports off of your models. This is most popular for our Form 3s with the like light touch supports. It is a great way to do your post-processing very, very fast. For big chunky models, I'd say this is probably the most efficient way that you can do that for removing all your supports. And honestly, once you figure out like the motion of the twist and pull, it is one of the fastest things that you can do to get supports off of your parts. And it is like kind of messy, I'm not gonna lie. It can leave behind a lot of marks on your parts. Sometimes it can leave scratches and things like that. But if you're just doing this as like a very quick, like I need a quick model as like a visual, that is definitely something you could do. You can just like twist them off, pull them apart, and you're good. The reason that we kind of like recommend a lot of these things and some of these additional kind of like tips is that you actually want to leave behind like a lump on your parts is actually preferable. A lot of people don't really think about that. They want it to be as flush as possible. Or when you're ripping off supports, you can actually leave a divot in your part. So we like to recommend ways that you can actually leave a little bit of extra material that you can then sand off later. And that's actually how you get your smoothest finish, because if you're taking dimples out of your parts, those are actually probably going to be way harder to sand out, way harder to finish. And you have to sand off layers of your actual finished part in order to get there. So we usually recommend that you leave a little bit of a bump, which most of these are going to do the trick for. Pulling off your supports is a little tricky, but sometimes you can get it to work, sometimes you can't. Next, I'm going to talk a little bit about dyeing. This is a little bit more of a fun topic rather than like this is how you should be doing your things. So dyeing parts is actually a relatively easy way to make improvements to your final production pieces. For the most part, we do this with fuse parts. These examples are mostly like nylon 12 parts, both in white and in the original. What we use, for the most part, is RIT dye, where basically you just take a little bit of RIT dye, put your parts in the RIT dye, you pressure cook it for a little while, and then you have a colored part. This is really great for like not wanting to add any additional like coatings or materials onto your part. You still want it to be your original material, you still want it to be your original parts, but you want it to have some color. This can be really nice for like examples of things that you're going to be showing at a meeting. Maybe you're showing your customer that what like the final part might look like if it actually had a little bit of color, and this can be like really good and representative. Or you could be delivering a final part and you want it to actually have some color rather than just being gray or white. Some people do desire those things, and that's totally fine. But if you're looking for other options, this can be like a really easy way to kind of step into that world. So if you're looking for something that can give your parts a little bit more color, RIT dye is a good option. In terms of like SLA things, I don't have any like good examples up here, but like if you want to dye your SLA parts, usually you have to add things to the resin. And if you want to do that, I highly recommend you reach out to us and ask before you start adventuring off on your own. We do have recommendations for that, but dyeing nylon is actually pretty easy, and like it's after the part is already done, so there's very little risk to doing any like damage or anything to your actual part. Electroplating is another kind of just like additional thing that you can do to your parts, kind of like after your print has been completed. This is a little bit more of an advanced one. This is not for everyone. However, it can have like great benefits for your like final parts, especially if you're doing very complex geometries that you want to have kind of like metallic properties. So electroplating, you kind of have to have a good setup for. A lot of people who do this, they either have their own setup in their lab somewhere, or they are outsourcing to someone else to do this, because it is a little bit more of a challenging one, but it comes out with like really great results. So basically what you're doing is you're taking your material, you're electrocuting all of it, and you're moving your material over to the other one. So that's kind of how you're getting your electroplated part. You get a pretty clean and smooth finish off of this for both SLA and SLS parts. You can do this on both. And they actually come out pretty clean, pretty smooth. It can be slightly unpredictable in terms of like some of the finishes if you're not doing it quite right. But if you are kind of like getting it going, it comes out very smooth, and it kind of like gives you an increase in structural properties because it gives you a shell of metal around your plastic, so it gives you extra structural properties. It also makes your parts then conductive, so you can add conductive properties to your parts without having to add anything to your material overall. You just kind of add a coating to it instead. And it's still very lightweight, pretty low cost, instead of making like full metal pieces, which can be rather expensive to machine. You could just kind of like add a coating on the outside, and that kind of helps with the cost, or just give your parts a metallic finish if you just want them to look that way. Is also a good option, and can also be very beneficial if you are trying to show this off to a customer and you're like, hey, I want this part to eventually be a metal component. This is what it will look like. You can add an electroplated coating of whatever metal that you are trying to show off, and that will give you kind of a good idea of what the results will be. The weight will be a little bit different, but the part will look the part. And then my last topic for today, I'm going to talk a little bit about polishing. This is one of our most sought after, most asked questions that we get on the services team and just at Formlabs in general. People want their parts to be shiny, particularly the clear resins. They want them to be as clear as they can possibly get them. So for SLA, there's a lot of options out there for how you can get a little bit of a shine and a little bit of polish on your parts. It doesn't have to be super duper intense. You can get super intense, but you don't have to. So we have a couple of like different examples kind of like on this slide of like things that we use in order to get a little bit of shine. If you're looking for something really, really easy, you can just go in and you can just like get a piece of sandpaper, sand off those little support nubs, and then just add a little bit of like mineral oil. For when I first got here, they handed me a bottle of Johnson's baby oil and said, put this on your part. And I was like, okay. And it adds like a really nice shine. If you are like sanding your parts, or if you scratched your parts when ripping off supports, it can help kind of get rid of that like dusty look, or kind of like disguise some of those scratches. So using like a little bit of mineral oil, you can rub it in with a paper towel, you can rub it in with your hands, and it actually comes out with like a pretty nice shine on it. And that's kind of like the easiest thing that you can do to add just like a little bit of shine to your parts. If you want to get a little bit more advanced than that, you can get a clear coat of paint of some kind. You can just kind of like spray that on. This one's a little bit trickier for much more complex like geometries, because you got to make sure that you're painting all the nooks and crannies to get a nice smooth finish. But if you have like relatively flat parts, actually like spray painting your parts with just like a clear coat. Most clear coats work. I don't know if we have like super specific recommendations, but I'm sure if you went to a hardware store and asked somebody like, hey, I want to put a clear coat on a piece of plastic, how do I do that? You'll probably get a couple of really good answers, and be able to just kind of like grab one, spray it on there, and get like a much nicer like clear finish. It kind of just like helps polish things off. Additionally, you can paint on either a clear coat, a clear paint of some kind, or you can paint on actually an extra layer of resin. So if you take like a paintbrush or something and you dip it in the resin, you can actually like paint that over, or you can dip your parts into a layer of resin. If dimensional accuracy is like super important to you, this is maybe not your best option. However, it does make your parts super duper clear, and if you can then go in and like maybe like polish up and change the shape a little bit, that is also probably going to look really nice and give you a very, very crystal clear kind of like infill on all of your parts. And then lastly, I kind of wanted to mention something that is also much more popular in our dental medical spaces, but using a polishing wheel with a little bit of just like polish on it, putting your parts up there and just running it through after you have sanded your parts can give you like a fantastic shine on a lot of your parts. Going through and making sure, and you just run it through a couple times. It's usually really, really quick as well. Like you don't have to spend a lot of time on it. Just take a pair, like this person is not wearing gloves, but if you wanted to, you could take a pair of gloves and just like run through it, and that way you don't get it on your hands. So these are kind of just like a few tips that I have for SLA. And then for SLS, I wanted to talk a little bit about polishing these parts. SLS is notorious for having a little bit more of a crunchy surface, as I like to say. So it is a little bit rougher, it's not quite as smooth as like our SLA parts. They come out, they have a pretty smooth side. So I want to talk a little bit more about like cleaning these and like making them a little bit more shiny and a little bit more smooth. So you can take your sifted potato that is covered in powder. It's very crunchy. You take that, you put it into, well, we use the blast, but you can put it into any media blaster with a little bit of glass media, and that at least gets you a nice clean surface and removes most of the dust that you're using. That's gonna give you like a pretty clean, pretty nice finish. Most people are done, they're good with that. However, some people want something a little bit more finished and also wants a smoother surface to do some of these other post-processing steps. So if you wanted to add like an additional coating on top or something like that, this is a good way to kind of like start that out. So you can kind of like compound the just like the outer surface of your parts. There's that porous like first layer on your fused printed parts that basically with the polishing system you should go in and you pack them all together, make it much smoother, gives it a nice shiny look. And this can be done with the blast, or if you want to do it in some other way, you can with another kind of like polisher, tumbler. We recommend the blast just because that's how we made it. So like this is super automated in our own system, but can be made to work through other systems if you are really looking to do so. So that's it for me. I am now going to hand it over to my good friend, Tsao, a renowned name on the services team for getting very innovative with finishing and getting lots of things done. So I'm going to hand it over to Phil.
Thanks, Brigid.
Let's go. That's back.
Okay, cool. Thanks, Brigid. I'm losing my voice a little bit because I've been like having too much fun talking to everybody, so probably should have paced myself, but I apologize if it cracks a little bit. I'm pretty thrilled to be here. I've known many people at Formlabs for many years, and yeah. So my name is Phil. I'm a mechatronics engineer. I have a background in mechanical, electrical, software, and firmware engineering. I've worked in various industries from medical imaging, particle accelerators, robotics, and consumer electronics. I'm also the founder of Ember Prototypes. We're a small, bootstrapped, rapid prototyping, consulting, and product design firm in Vancouver, Canada. I fell in love with 3D printing back in 2013 and started my SLA journey with Formlabs in 2018. And Formlabs has been a really big supporter of me ever since. So here's a picture of our small space at Ember. It's around 200 square feet, which is kind of crazy. And we use 3D printing in 3 main ways. The first way is we print as a service. So these are some example parts for a skeletal traction kit for a local medical company called Arbutus Medical. We also use 3D printing to... Do the videos not work? Okay, I guess the videos don't work. It's kind of a problem. But anyways, we use 3D printing to design and iterate on complex products like these air quality devices for Haven IQ. And we also use 3D printing to design and produce our own in-house products, like these optical calibration tools for multi-head FDM 3D printers. So I think we all can agree that post-processing kind of sucks. And throughout the years, I've learned some tips and tricks to make it suck a bit less. And I want to share those with you today. So I know this presentation is called post-processing, but I truly believe that the path to a perfect part starts at the beginning. So Preform is a pretty amazing piece of software. It achieves very high success rates and works out of the box for a lot of different materials. It also has some very powerful editing features that, if you understand how to use, can really help make your life easier when it comes to post-processing. Okay, so this was supposed to be a video. All right, well, it's not a video, but I'll kind of describe what it was supposed to be. This is a pretty complex heart model in elastic 58 resin. And it's a very difficult part to print. There's a lot of cavities, it's thin-walled, it like bounces around a lot when you print it. And what I wanted to show was that sometimes auto-generation doesn't put supports exactly where I would like them to be placed. And using some of these editing tools can really help when it comes to difficult parts like this, but also when it comes to post-processing. So I'll kind of describe in words what this was supposed to look like. Basically, for this part, if I hit auto-generate, it would create a whole bunch of supports. It would also put some supports in the center of the heart, which is not what I would prefer. So, and then if we flip to the back, it would also not support the back of the heart with much density, but it would support these mounting points with very high density. So it wouldn't support the back enough, but it supported the mounting points too much, which made support movement difficult. So what I was going to show is that using the manual editing tools can be really helpful. And my workflow was basically, I would disable internal supports, and then I would use the support paintbrush to manually put supports on the back of the heart at the density that I want. And then I would also support all the local minima on these parts and add additional supports where needed, and then step through layer by layer to like inspect that everything is okay. It's a bit hard to visualize without the video, but using these tools can really help with difficult parts like this, but it can also help with post-processing. So this is the heart model fully printed. If any of you guys print in elastic 50A, I think you'll appreciate how hard it is to get really clean parts like this. Another example of where using these editing tools and pre-processing can really help is shown here with these parts. So on the left side is a rigid 4K part that's been auto-generated. And on the right side is me aggressively removing supports from the inside and outside faces. Not only does this mean I don't have to sand the part as much, but it also leads to a pretty significant reduction in resin consumption. If you're a beginner, I don't recommend doing this because it can increase the chance of part failure. But with experience, knowing what you can get away with can be really helpful for minimizing sanding and post-processing, especially if you're making these parts in any production capacity. So the next topic I want to discuss is sanding and polishing. But from a perspective of I hate it and how can you not do it? So Formlabs' low force technology is already very impressive. There's many cases where you can take supports off and not have to sand your part. But there are ways that we can minimize the need for that even further. And that's by lowering touch point sizes. So I've shown a table here, and on the right side are the support sizes that I typically run on parts. You can see that they're routinely 0.1 to 0.2 millimeters smaller than the default print settings. That doesn't seem like a lot, but it's actually quite significant when it comes to sanding and post-processing. Again, if you're a beginner, I don't recommend doing this because it can increase part failure, but with experience, this can work really well and save you a lot of time. That was also supposed to be a video, but you can see here that if you lower touch point sizes and you are careful about where you locate your supports, you can get pretty flawless parts that just come off the supports with a perfect surface. So that top surface here was the supported side, and it's flawless and does not need sanding at all. Using some of these tricks also means that you can get pretty good optical transparency without the need to do any sanding or polishing. A lot of the things we see on YouTube and stuff is like people sanding for hours, people polishing on a wheel. But here are some examples of 3 parts that we printed in clear resin, took off the supports, and just sprayed with clear coat. And you can see that they have pretty acceptable optical clarity. I have 2 last tips for this section. The first tip is we use a mixture of 80% Novus and 20% mineral oil in a small spray bottle, and we mix it together. And we use that to polish parts without leaving an oily finish that just mineral oil would end up doing. And the second tip is that I will often remove supports from parts before curing because it tends to leave a much cleaner finish and result in less sanding. But there are some caveats around that. And so that leads me into my next topic, which is about curing itself. Formlabs has a very impressive material library, and in my opinion, is like the biggest reason to adopt into the Formlabs ecosystem. These photopolymer resins all require a heated UV post-cure to unlock their maximum mechanical properties. But this same heated cure can sometimes lead to warping with certain geometries. This depends on a bunch of factors like part geometry, print orientation, material property of the part. For example, flexible thin-walled parts are more likely to warp than thick rigid parts. To combat these edge cases, we've come up with a flowchart that has worked for the majority of things we do, ranging from our service bureau to our product design work. And how this essentially works is, the first question is, we ask ourselves, do we need the exact mechanical properties that are specified in the data sheet? In other words, are these parts just for a fit test, for an investor demo, or do they need to be load-bearing and fully functional? If they don't need the exact mechanical properties, then we will almost always remove supports first before we cure to minimize post-processing, and we'll cure it without heat for 3 times the duration. And this has always prevented warping from happening. If we do need mechanical properties, then we'll ask ourselves, is the part large, long, thin-walled? If it is, then we have to leave supports on when they go through the standard heated cure. If they're not, then we can often get away with removing supports before they go into the standard heated cure. This is an example of a product that I designed, and we had printed 100 of these enclosures for a beta test. Because of the part geometry, print orientation, and material property of these parts, the gray parts specifically, they had a tendency to warp when they went through the standard heated cure. So following our flowchart, in order to minimize or eliminate warp entirely, we ran those through with no heat for 3 times the duration. And so my last topic is something that I think we seldom talk about in the additive manufacturing industry. So I'm pretty thrilled that Formlabs wanted me to share this. And it's about how we minimize our waste. So SLA 3D printing requires a solvent to wash off excess resin from your parts. And once the solvent is fully saturated, it needs to be replaced and disposed of. We used to pay a chemical treatment facility to take our waste, only to find out that they burn it. Like, they literally incinerate it. So we wanted a better way to deal with our waste, and we talked to our friends at Formlabs and ended up buying a solvent recycling system. So how this works is that basically you essentially pour your saturated resin into this bag, and this machine will boil it, condense down the vapor into a new bucket, and you have crystal clear fresh IPA in that bucket. And all the solid waste is left in this bag, which just gets disposed of. Again, this was a video, but that's okay. What this means is you don't have to store as much IPA in your space. It's more cost effective, it's more convenient, and it's also just better for the environment. So for our business, it's been a no-brainer, and I would highly encourage everybody else to at least look into solvent recycling. That's all the time I have for today. If you want to chat, I'm on social media, I'm on YouTube. I'm active on the Formlabs forums. You can come chat with me after this. Thanks for your time.